Okay, this is the P1 paper from October 2023. It's question number 6, and this is a quadratics question and an equations and inequalities question. This first part here, within quadratics, we're going to be looking at the discriminant, and then the second part here, in order to solve that, I'll need to solve a quadratic inequality. Okay, so 2 different chapters, but question is not too bad. Let's make a start to it. It says for part A, if we solve this equation for p minus 2x is equal to 12 plus 15p over x plus p, when I do solve that, it'll have 2 distinct and real roots. So what that's telling me is when I go through the process of solving this, I better end up with a quadratic. And if I do end up with that quadratic and I do b squared minus 4ac is greater than 0, this should fall out of it. So let's go ahead and do that. So if I'm trying to solve this, I would say 4p minus 2x all multiplied by x plus p is equal to 12 plus 15p. Now remember, we're going to be trying to get to this, so don't do it too quickly. Don't miss out any stages, because in effect it's a proof as we're going through and doing it. So I'm going to do it really slowly. You don't have to do it quite as slowly as me, but I'm going to even leave the 4 out here and just multiply this by this and this by this and see what that comes to. You can do this yourself, obviously. I end up with, what have I got? Px plus p squared. I've got minus 2x squared, and I've got minus 2xp, or px. It doesn't matter which way round we write that when we're doing it. And then tidy up that bracket. And in fact, I'm going to multiply it all out as well and tidy up the bracket. So 4 lots of p squared is going to give me 4p squared. These two will both make minus px. So I've got minus 4px, and that x squared will be multiplied by 4 as well. So minus 8x squared is equal to 12 plus 15p. Yeah, so I've got the beginnings of a quadratic equation. I really want that 8x squared to be a positive, so I'm going to take everything over to that side now. So if I do that, I'll end up with 8x squared, I'll end up with 4px, and then for the constant, I'm going to end up with 12 and the 15p, but then minus the 4p squared is equal to 0. So there's my quadratic, where I've got a, b, and all of that being c. So what I might just do is put that in a bracket. Like, you don't have to, but if I put that in a bracket, might make it a bit clearer for the examiner. I've been told there are 2 distinct roots in this quadratic. So if there are 2 distinct roots, our discriminant b squared minus 4ac, when we've got 2 different roots, then that's greater than 0, and we've got obviously all the variations of that. So b squared, 4p all squared, minus 4a, and then, as I say, c is all of this, 12 plus 15b minus 4p squared. All of that's going to be greater than or equal to 0. I know what it's going to work out to be. It's going to work out to be this, but don't be in too much of a rush to get there. Just go through steadily. It's a proof, so you want, whoops, and then put 4p squared. 16p squared. It's 32 multiplied by everything in the bracket, or minus 32 multiplied by everything in the bracket. So minus 32 times 12 is going to give me minus 384. Minus 32 times 15 is going to give me minus 480p, obviously. And then 32 times 4, or minus, it'll all cancel out to be plus 128p squared. And say this isn't the answer that they've got up there, but let's just tidy out what it does work out to be. That works out to be 144p squared minus 480p minus 384 is greater than 0. And then in order to end up with what I need, I have to divide everything by 48. And if I do that, I end up with the 3p squared, I end up with the 10p, and I end up with the 8 there being greater than 0. So wonderful, that's the first part done. And then for the second part, it says, right, by using algebra, find the values for p, so basically solve that quadratic inequality. So if we're solving a quadratic inequality, we've got 3p squared minus 10p minus 8 is greater than 0. What we do is we find the critical values. Okay, I basically know it's going to be something like that, and what I'm trying to do is to find those two critical values first, and then I can say where my solutions lie. I will actually include that graph in a minute when I'm doing it. So I try and use the correct wording for this. So for critical values, I can change this inequality into an equation because I'm interested in where it hits the axis. So I get that to solve. Now they've set this up, so I'm almost certain this is going to factorize. I'm not going to go through the process for factorizing that you can find on other videos on this channel, specifically designed for factorizing a quadratic. I'm going to leave it like that. So 3p plus 2p minus 4, which gives me 3p plus 2 equals 0, which is p equals minus 2/3. Or p plus 4 equals 0, which gives me p equals minus 4. But then remember what I'm trying to do. I'm trying to solve the inequality. So if I know that this is a positive quadratic, well, I know a positive quadratic will be that shape. To be fair, I don't know whether it's over here, or as I've got there, but I do know that now because I know that this value here is minus 2/3, and I know that value there is 4. Sorry, let's just tidy that up. That was p minus 4, which means gives me p equals 4 there. Apologies for that part there. So then, yeah, I want to know when is this equation greater than 0, or inequality, sorry, greater than 0. So it's in those two regions there, isn't it? So my actual answer then is going to be p less than minus 2/3 and p greater than 4 as my actual final answer there. Make sure that you do that. It's a really good idea to draw a sketch for it. A lot of my students have real problems in doing that last little bit and showing all their working out clearly enough. So hopefully that all makes sense to you.